What's up everyone, my name is Matt, and in this video I'm going to be showing you some of the basics of computer programming in Python. This video is specifically geared towards beginners and with a special focus on using Python to do some really cool math features to help you with any kind of math problems that would take a long time to do on paper with a calculator, but would take your Python a really short time. In the description below, I have a link to a website called Jupyter Hub, which you can use to write Python code for free. You don't have to download any software nor extensions, so you can do everything in Jupyter Hub if you want to. And so let's get into it. So we humans are going to relax and let the computers do the hard work. Alright, so the first thing I'm going to teach you how to do is how to output content on the screen. We're going to do that using a print statement, and it goes like this. So do print, then if you want to do text, you have to put some text in quotation marks, such as this. And remember to put pair of parentheses, quotation marks, and you do Shift Enter in Jupyter Hub to print the message out on the screen. And here we go. And if you want to do numbers, you don't even need to do the quotation marks. If I want to print 39, for example, you can just put 39 without the quotation marks, and it'll be all. The next thing I want to show you how to do is how to define variables and store numbers within them. So let's say we want to print the speed of light. Let's call it C, and the speed of light is 299,792,458. And we want to print out the speed of light. We don't necessarily have to print out this entire number. We can just do print C, and it should work like that. The variable we defined in the previous example wasn't actually much of a variable because it doesn't actually change. It was more like a constant. So right now I'm going to show you how to use variables that can actually change. And the way we're going to do that is we're going to define a function. So I'm going to define a function. Let's find the function of a hypotenuse of a triangle using the Pythagorean theorem. So Pythag hype, this is the name I'm assigning to my function, and let's call it a function of A and B. Here you put in brackets the input parameters. These are the independent variables that you're going to feed into this function, and the function is going to return an output. Don't forget to put a colon on the edge. And so I'm going to write an equation for the Pythagorean theorem. So we have to put return because the function has to return an output. And the Pythagorean equation is, I'm going to write it out. It's going to be a squared plus b squared, and then take the square root of that. These double asterisks means exponents, so this is the notation to use for exponent. Exponents in Python, I'm using exponent 0.5 to do square root, which is just taking to the power of 1/2, which is the same thing as square rooting it. And so we've defined this function of two variables. Now let's assign values for A and for B. For the sake of simplicity, I'm going to use a 3, 4, 5 triangle. And let's call a variable H equals Pythag hype, then of A and B. So this variable is actually a variable because it changes depending on what A and B are. So let's print out H, and should we get 5? And it does work. Moving on, I'm going to show you how to do some features in math using the math package that's automatically stored within Python. So we're going to start by importing, use import math. This is a package called math that's free for Python users to use, and we can call different functions from within it, which I'm going to show you in a second. So one of the functions, the first one I'm going to show you is pi. The math has the value of pi stored within it. You call it by printing math.pi. And it should print out the value of pi for you. Now it also has trigonometric functions such as sine. So let's print out the math.sine of, let's say, try 0. And it should be 0, which works. And it also has cosine, which is the same thing as just cos. And let's try to take the cosine of pi, which we know should be -1. And here we go. And lastly, let's try tangent. Let's try tangent of, let's also do pi. Pi. And there we go. Note that this value here is and only an approximation because Python can only store so many digits, and it actually calculates these trigonometric functions with an infinite series, which I'm going to show you later on. But note that this is extremely tiny number, so it's supposed to be 0, but Python's getting a little bit off just because it can only use so many terms in the infinite series. And one other thing to note is that these values inside sine, cosine, tangent, any trig function have to be in radians, not in degrees, otherwise it's not going to work. Now, the math package also has stored Euler's number, E, so we just call it by doing math.e to print out Euler's number. We can do exponentials with E, and so that will be math.exp. This means E raised to the power of whatever we put in here. So let's try 1. This should give us is E. There we go. We can also do natural logs as well. So that would be print.math.log. Let's try log of E, which should be just 1. There we go. And let's do one final test. Let's do print math.exp. So E raised to the power of the natural log of 2. E raised to the power of a natural log is just whatever you take in the natural log of, so you should get 2. Whoops, what's going on? Well, I missed a parentheses, so let's fix that, and here we go. And it all works out. The things we've done so far is basically Python can do it, but we can do it too, just as easily with a calculator. Now I'm going to show you something that we can't do just as easily as Python can do it, and that is a for loop. Now, what a for loop is, it basically iterates a line of code a specified number of times. So yeah, I have some code written here. I'm defining a function called sum series. It's a function of n. And so here I have a for loop. So what this is doing is that it takes this line of code and repeats it a specified number of times. Here, specifically, it's taking its parameter I, and it's ranging it from 1 to n plus 1. So what this for loop does is it first runs this line of code with I equals 1. Then it repeats it with I equals 2. And then it increments I by 1 every single time it repeats it. So it increments by 1, so I is 1, 2, 3, 4, 5, etc., until we reach this value. So as soon as I hits this value, the loop stops running. So actually, if we want it to run until n, we need to put n plus 1, because this is the value at which the loop stops. So it's going to run it n times, and here we're making n a variable because we want to vary the number of times that the loop runs. So what this function does is it adds I to x every time. So we started at x equals 0. So what this does is actually takes x, then it adds 1. Then it takes the new value of x, which is 1, then it adds 2. Then it adds 3, then it adds 4. So basically you get 1 plus 2 plus 3 plus 4 plus 5 plus 6, and etc. until whatever we want n to be. So let's try out some numbers. So let's do print sum series, and let's try 10 at first. We should get about 55, I believe, and it does work. Now let's try something crazier, and let's use 100, which would be really tedious, difficult to do by hand, even with a calculator, but Python can get the answer in less than a half a second. So that was a really quick overview of the math features that you can use in Python to help you do challenging and long problems. I hope you found this video helpful. Please remember to like, comment, and subscribe, and I will see you next time.